Hello, welcome to this presentation on Introduction to Support Vector Machines. So in this presentation, we will explore support vector machines, which are commonly referred to as SVMs, which is a powerful machine learning algorithm used for classification and regression tasks. So today, we will cover these topics in this presentation. First, we will find out what are SVMs. Then we will understand how SVM works. We will find out some of the advantages of SVMs and some of the applications of SVMs. And in the last part of this presentation, we are going to conclude what we have learned in this presentation. So let us first find out what are SVMs. A support vector machine is a supervised learning algorithm, means they learn from the labeled data. They primarily focus on classification tasks where the goal is to categorize data points into predefined classes. SVM achieve this by finding a hyperplane, which is a decision boundary in high dimensional space. The best separates the data points belonging to different classes. The key aspect of SVM is maximizing the margin between the hyperplane and the closet data points from each class. These closet data points are called as support vectors, and they significantly influence the position of the hyperplane. Now let us understand how these SVMs work. So first, you need to prepare your data by cleaning and normalizing it to ensure a consistent scale for all the features. If your data is not linearly separable, a technique which is called as feature mapping can be applied to transform it into a higher dimensional space where a separating hyperplane can be found. Then the SVM algorithm identifies the optimal hyperplane that maximizes the margin between the hyperplane and the support vectors. And finally, when presented with new data points, the SVM classifies them based on their position related to the established hyperplane. So SVMs are capable for performing both linear as well as non-linear classification. Now, these are some of the advantages of SVM. SVM offers several advantages. They are particularly effective in handling high dimensional data, which is common in many machine learning applications. Also, SVMs can achieve good performance even with small data sets, making them suitable for scenarios where data collection is limited. Furthermore, SVMs demonstrate some level of robustness to noise in the data, means they can handle slight inconsistencies without significantly impacting their performance. These are some of the applications of SVM. SVMs are widely used across various domains due to their high accuracy and robustness. In image classification, they are used for tasks like face detection and object recognition. In text classification, leverages SVMs for sentiment analysis, spam detection, and topic modeling. Bioinformatic analysis utilizes SVMs for protein function prediction and gene expression analysis. Even in the financial sector, SVMs find use in stock price prediction and credit risk assessment. So in conclusion, support vector machines are a powerful machine learning algorithm. They are effective for classification and regression tasks. SVMs are widely used across various domains due to their high accuracy and robustness. These applications are well suited for high dimensional data. The applications demonstrate the versatility and the effectiveness of the SVMs. However, they also have some limitations, such as being computationally intensive and sensitive to the choice of kernel and regularization parameters. So understanding these factors is crucial for the effective application of SVMs in the real-world scenarios. Thank you so much.